So in this presentation, we want to show that when you change the intensity of light, you're going to change the rate of photosynthesis. That means that the rate of photosynthesis is affected by light intensity. So light intensity basically means how much light the plant basically receives. Okay, so you can have different scenarios that actually show this in real life. For example, if you go to a nearby pond and then you look at the aquatic plants that are occupying the surface of this pond, you will realize that if there is any shade, those that the aquatic plants or the pond weeds that are under the shade are not growing vigorously compared to those that are basically receiving direct sunlight. So they don't have any shade, so the sunlight comes directly to them. You notice a difference, okay? And that difference is basically explained in terms of the light intensity that these aquatic plants receive. Okay, so we want to see in this presentation, can we change the light intensity, and then can we see changes that can happen in terms of the rate of photosynthesis in these plants? And the answer is yes, and that's what we're going to look at now. So what do you basically need? You need an aquatic plant. That means you need a plant that can actually live in water. And an example here is the aloe vera plant. That's what you can use. The second thing is you need a beaker or basically a container. And then you also need water where you will put that aquatic plant. Okay, and then you need a source of light. You can use let us say a lamp, okay, a desk lamp that you can adjust, that is movable, okay, because when we move, that is when we shall be able to adjust the light intensity. Okay, and then you need to have a lure. You will need this lure for you to determine the distance at which you're going to place this lamp. And then you need a stop clock or stopwatch to basically time. Okay, you time. We'll see how to use that. You need a scissor for you to cut off the part of the aquatic plant that you need. And then you also might need sodium bicarbonate. This one will provide you with the carbon dioxide such that you don't have carbon dioxide as being the limiting factor in this experiment. Remember, carbon dioxide is required for the process of photosynthesis. So therefore, if you don't have carbon dioxide, you will not have photosynthesis happening at a faster rate. So you don't want to your experiment to take so long because the plants are not having sufficient carbon dioxide. So you can provide that carbon dioxide by dissolving sodium bicarbonate in the water. So what do you start with? The first step is that you fill the beaker with water because you want the aloe plant to be in water. That is its natural habitat, right? So in that water, you add a pinch of sodium bicarbonate, and I've explained why you need to have that. And then you can cut the part of the plant that you want, that is the aloe plant, put it in water, and then ensure that you get the plant, this aloe plant, which is healthy, okay, and green. That means that it doesn't have any disease that is affecting it or that may affect the rate of photosynthesis. You don't want to have that. So you get a healthy one, which is very green. and then you put it in your beaker of water. Basically going to do, the theory behind this experiment is that you will put the lamps at different distances such that you have different intensities of light reaching this Elodea plant, which is in the beaker with water with dissolved sodium bicarbonate. Okay, the logic is that when indeed this plant makes food, that is photosynthesis, oxygen is going to be released. Okay, and that oxygen is going to be released in form of bubbles. Okay, in form of bubbles. So you'll be interested in counting the number of bubbles that you're going to be released, that the Elodea plant will be releasing in a given period of time. That's why we have the stopwatch. Okay, so your setup is going to be as follows. You're going to have the same Elodea plant, the same setup. You get the Elodea plant, put it in a beaker containing water, where you have also put your sodium bicarbonate. So what you're going to do is that you'll be adjusting the distance between the setup and the lamp. Okay, that distance, it means that if the lamp is closer to the Elodea plant, it means the Elodea plant will receive more light. But when you move it away, it will receive less and less light as you move it. So you can decide to put the light in the first setup at 10 centimeters away from the Elodea plant, and then for the second you can put it at 30, and then for the third you can put it at 50. Okay, so that means that you're continuously moving the light away from the Elodea plant. Now the next thing, before you start counting the number of bubbles in this experiment, because this is the number of bubbles will actually tell you the extent to which the Elodea plant is actually photosynthesizing. Okay, if you have more bubbles, it means more oxygen is being given out, and remember, oxygen is a product of photosynthesis. So before you start counting the number of bubbles, make sure that you leave the setup for at least 5 minutes before you start counting the bubbles, such that the plant gets acclimatized to these new conditions that you have put it in. Okay, so that's what we mean here by acclimatizing. Okay, so after that, then you start your stopwatch, and then count the number of bubbles that are going to be released in 1 minute. At each point, at the point of 10 centimeters. And then you repeat the same thing at the point of 30 centimeters, and then also at the point of 50 centimeters. You still count the number of bubbles that are released every 1 minute. In 1 minute, how many bubbles are you getting? Okay, still, it is still very important for each of the steps, like I said earlier on, that you give 5 minutes for the plant to get used to the new environment or to the new conditions. Okay, so you can repeat the experiment thrice. Okay, try at least thrice, such that you have some consistent findings. Okay, in science, you don't take a single finding or single measurement. It's better for you to take several measurements, such that if in the first measurement there was an error, in the second measurement perhaps you can identify that there was an error. So that's why you need to take several measurements. Okay, it's very important that the top of the beaker is actually covered by an aluminium foil, such that it cuts off the light Okay, such that you need the only light that is affecting the experiment is that is coming from the bulb. That's very, very important. What could you expect? You could expect that at shorter distances, you have more bubbles compared to when the lamp is at a distance. Okay, so that means that when the light is far away, you have less photosynthesis happening compared to when the light is closer. So when the light is closer, you have more light intensity compared to when the light is farther away. Okay. Okay, so that is what you could expect theoretically. But if you do this experiment practically, we could expect you to have a table where you have the number of bubbles released at 30 centimeters, at 50 centimeters, and also at 10 centimeters. So you look at the data that you have collected, and then you will see that the more you move the light away, the less bubbles you have. And that will definitely mean that high light intensity increases the rate of photosynthesis. So that means that the faster, when you have high light intensity, the rate of photosynthesis is also faster. Okay. Why is that so? This is so because in the process of photosynthesis, we have what we call light-dependent reactions. That means that these reactions cannot happen if you don't have sufficient light. Okay, so that's the same logic that we have for why the pond weeds that are under the shade are not growing vigorously compared to those that receive ample sunlight. It's because their rate of photosynthesis is limited because of the limited supply of light. Thank you.